media techniques in Android specifically. So the next few topics will all be illustrating different aspects of the Android framework itself, so that you can make use of these features in some of the applications that you're implementing in practice. So multimedia techniques in Android. How what is done now? On the website, I have a list of several places where I often go to fetch information about different features. The multimedia aspect of it, some of it is there on the Android developers website. There is one more place where I consulted called wiseandroid.com. There are many other places where people post little snippets of code, blog posts explaining how to do different things in Android and so on. I have links to a few of them on the course website. You might find more by doing a Google search. There may be more people now that are posting new ideas. So if you are stuck for an idea that you want that you are trying to implement within your application, one suggestion would be to also do a Google search to find people who might have posted little explanations of how things can be done within Android. So reading the textbooks may not completely answer your questions. Reading the developer's website may not completely answer your questions. Sometimes reading some of these little blog posts from different people might give you ideas on how to solve little problems. And one place which I've consulted is this blog called wiseandroid.com. So some of the multimedia things I actually learned by reading a couple of blog posts on this particular website also. Now, within Android, what kind of multimedia support is available for you? Android provides all different kinds of multimedia support. For example, for audio, all the standard formats that you are familiar with, MP3, MP4, OGG. How many of you know OGG? OGG is an open standard for encoding audio, just like MP3. OGG is another. Anybody has taken either the multimedia course or the computer music course here? Did they deal with these things in any of the courses?
No.
Audio standards, video standards, and so on? They didn't?
Brief.
Multimedia? Okay, briefly. I'm even more briefer. Just one bullet point. I mean, from our perspective, all that we are interested in this is that audio is encoded in some formats, and Android supports many formats. That's all that we are interested in. Okay? Android has a wide support for many different formats. Video also, Android supports all the standard video encoding techniques. For images in Android, the preferred mode is PNG, portable network graphics. If you can't find PNG, then use JPEG. If all else fails, use GIF, although Android people recommend you not to make use of GIF as far as possible, because scaling to different screen sizes is not as straightforward. GIF doesn't do such a good job, apparently. So preferably PNG, which is a lot more better for handling scaling of the screens and so on. Yes, so several different media formats and several different codecs are supported in Android. You can play audio and video either from raw resources that are stored within the application itself. The example that I just showed you is a case where I used raw resources. I embedded the music file directly into my application. That is obviously a stupid way of implementing an application, but my intention was to show you how to play it. But you can actually access media files that exist on a file on the file system in Android, or you can make use of a content provider which might provide you with a list of all the audio or video contents that are available in Android. Subsequently, I will, when I talk about databases, I will come to that point, and then I'll explain how you can get access to all the media files that exist on your device and be able to list them and then in your music player. Actually, I will later on modify this music player that I just showed you to include another feature which lists all the audio files that are there on your device and then allows you to play any one of them using the same simple media player that I just implemented. So from standalone files also you can examine and find out the media files that are existing on your device, or you can even establish a network connection to a server, a media streaming server outside, and then get the media coming in from the server. For example, if you are implementing a YouTube player within your application, that will be a place where you would go and fetch media from a server and then play it out within your application and so on. So over the network fetching data is also supported in Android. How is it done in practice? Now, within Android, there are 3 different categories of media supporting libraries or media supporting features available. First and foremost, we will talk about something called the media player. The example that you just saw of the media player, basic media player, I made use of the media player. Media player has certain features that are suitable for certain purposes. The next kind is something called SoundPool, and then there is an even more advanced thing that will allow you to actually even create sounds by using audio spectrum and so on. If you're taking computer music, for example, you can even program the Android device to create sounds that you want to do. If you can go into raw frequency level coding of actual sounds and so on. So for example, if you're implementing, say, a piano application on your device, you may make use of this in order to generate raw sounds directly in terms of certain frequencies and so on. So 3 different categories, each with different levels of complexity. The simplest of them is the media player, which allows you to play media files on the screen, and then together with it there is something called the media recorder for media recording, that is to capture media within your device and so on. Now, fortunately, the media player and the media recorder, the way they are designed is that when you make use of this class and then play music using or record music using these, they create their own background thread that is already encoded into the class. So you don't need to explicitly create a background thread. So that's why in the service class, you saw me invoking this player and then directly playing the music file. The background thread for playing the music file is automatically created for you because it is very often used in practice, so that's why it is already supported. Now this media player class supports both audio from a file as well as stream-based data coming in, stream-based audio data coming in practice. Okay? If you need direct access to raw audio, then the 2 classes actually, this is the most generic one called as audio track and audio recorder class. That will allow you to generate raw sounds directly by programming the device. So these are very useful if you need to, for using this you really need to understand how to generate sounds and music and so on. Now, generating sounds and so on is beyond the scope of this course. That is a computer music course by itself. So I will not go into details there, but I will briefly tell you how to make use of these audio track and audio player, audio recorder classes. Now, but the audio track and audio recorder classes, they do not create their own thread in the background. So if you're making use of them, you need to create your own thread and then do them. I think this is idle. And so when you hit reset, your application, your media player is in the idle state, and then okay, I can read it better here. Okay, idle. So this is set data source. This is how you supply the source of the data. If it is a raw file, then you simply use the create, but in other cases you can specify where the file is coming from. If the file exists on a file system and you want to play the file, then you use this function called set data source. And then this is the state called initialized. In the initialized state, then when you call the function prepare, then the media player is moved into the prepared state. And from the prepared state, when you call the start method, then from the prepared state it is moved into the started state. From the started state, you can move the player to, when you call the stop method, from started you get to the stop state. When you call the pause method, you get to the paused state. From the paused state, you can go back to the started method by calling the stop, by calling the start method. And from the stop method, this is playback completed. This is the playback completed. So if you set looping to false, then it will go back again and keep repeating. And seek to in playback completed, you can use seek to move to a specific location on the track, and so on and so forth. So as you see, this interaction, this state diagram basically represents how the media player class moves from one state to another state in response to calls to various methods within your various methods that are part of the media player class. Okay? Now, okay, we still have a couple of minutes. Now, this is the list of all the media player methods. As you see, I explained how to create a media player, how to specify all the different things for the media player, and so on, and then how to start and stop the media player. And so on. You saw the use of these things in the example that I just showed. Now, what I will do is I will call the stop method at this point, and so we will call the unpause method on Friday. Okay? You didn't get it, right?
Somehow get it.
You understand what I just said?
Yeah.
I called the stop method on myself. So I'll call the resume method on Friday. Next class is initial phase. So how do you create a media player? If you want to make use of media player within your code, you need to declare this media player variable within your code. So you have to create the media player. Then, once you create the media player, then you need to specify the source of the actual data that is being used for the media playback. If the file is already embedded into the application as a file in the raw resources directory, then in that case, you can simply specify the file by using this particular approach. You directly specify the file, saying media player create and this one. If on the other hand, if you are playing out the file from a if you are playing out the music or sound from a file that is part of your local file system, or you're you are downloading a stream and then playing it back, then you set the data source of the player by this method and then specify the path of the file. Path is like a URI for the file that you're playing out, and then you have to call this method called player.prepare, and then once that is done, the player is ready. Then you start playback by calling the player.start method. So whenever you want to start the playback, you call that method. Pausing, stopping, and once you are done playing the file, then you call player.release. At this point, the player has stopped doing its work. So this is how you make use of the different methods of the media player. Subject. Java for Teacher is also to tell you how to live your life. Confucius was a teacher, right? He was teaching people. And I believe that we as teachers should also represent his ideals very well. Okay, going back to media, this is media player. Then for video playback, where did media recorder go? I thought I had the video. Okay, maybe I think it is after the video playback. For if you are using video in your application, then video playback and recording is also supported by a media player. The same media player class supports even video recording. But for doing this within your application, in the layout, you need to declare this view inside your layout and then access that to display, to show the video on the screen. So this is how you do it. Once you declare this in your layout, you get a handle to that layout. Again, this you should know where it comes from. This is from your r.java file, and this is automatically created because once you put this in your layout, the XML file, everything that has a name there will have has an ID there, will have a corresponding ID being declared here. So this is how you refer. And then you can specify the video URI like this, and then some of the other methods for making use of the media player. Same thing. Okay. All right. And you need a media controller in order to, you can use a media controller to control the video playback. And these are the methods that you use for using the media controller for video playback and so on. Okay, this is the media recording. Suppose you want to record media, audio or video, for example. You can use the media recorder class, just like the media player, there's a media recorder class. Again, declaration of the different things. And I'm sure this is fairly straightforward. So you can take the player example that I gave you and turn it into a media recorder. That will be a good exercise for you to do on your own. Take the media player example that I gave you, turn it into a media recorder by substituting some of those using this particular set of method calls, and then you should be able to do media recording automatically. If that is something that you are going to make use of in your application, a good place to make use. But media player and media recorder provides a very rich API. But media player and media recorder are designed for long playing media streams. Things like music, audio tracks, long audio tracks, videos, and so on. That is, once you start up, it will play for a long period of time before you stop. So this also means that the media player supports things like seeking operations, selecting a particular location from where to continue the playback and so on, source buffering and so on. But unfortunately, the media player class is a heavyweight class, meaning that it is a resource hog. Okay? So if you're making use of media player, then you should remember that it takes a long time to initialize before the playback actually begins. So this is suitable for, that's the reason why we say this is suitable for long playing media streams. This is not suitable for low latency scenarios. Things like, for example, you need to create sound effects in games. Media player is not the right thing to use. Okay? And furthermore, within your application, typically you would expect 1 or 2 media player instances being created, not a dozen of them. Okay? In those circumstances, it's okay to make use of media player. But you have to remember that it is a slow to initialize process. So there is some amount of latency from the time you, for example, click a button to start the media playback and to the time the actual playback begins. But for long playing media, we are okay. We are willing to stay for a short period of time. If you have low latency requirements, then it is better to make use of the SoundPool class. What does the SoundPool class provide for you? SoundPool class manages and plays audio resources for applications. So in this case, what you have is you have a bunch of small, short audio tracks or media tracks. Then you gather them together into something called a SoundPool class, and then you can invoke different ones as and when you require. And the playback is very low latency. What happens is that the SoundPool class will decode. So for example, if you have an MP3 is a encoded version of the audio, right? From an encoded version, when you need to play back, you need to decode it first before you begin playback. And decoding takes time. That's the reason there is an additional latency before the playback begins. Whereas if you're playing games, for example, you want very quick response audio to be delivered. As soon as you hit a button, you want the sound to be generated immediately. In those circumstances, you just cannot afford to wait for the decoding of the video, decoding of the encoded streams to take place. In that case, we make use of SoundPool. What SoundPool does is, if you supply SoundPool with media files that are encoded, right at the time you initialize the SoundPool will decode the media streams back into full audios and then store it in memory, store it directly in memory, ready for immediate playback. So that's the reason it is able to achieve low latency playback. I will show you the code where we make use of this in place. So what the SoundPool does is that it will use the media play. If you supply encoded streams like MP3, like OGG, like MP4A, and other encoded streams, it will make use of media player to decode the stream back into raw audio and then store the raw audio in memory. And it uses 16-bit PCM. If you know anything about audio encoding and so on, you understand what this is. Pulse code modulation. If you have taken computer music course, you would know what it is. Or if you have taken the multimedia course, you should have been told something about this there. This is not the place for me to teach those things. But if you don't know, don't worry about it. It's not a big deal. From our perspective, we just need to know that raw data stream is required. And so what happens is, within your applications, you can supply the sound bits in terms of compressed streams, compressed encoded stream, encoded files, and then they'll be decoded by SoundPool right when you initialize SoundPool, and will be ready for being made use of within your application. The typical usage scenario for SoundPool is things like games where you need sound. And in addition, you need several sounds to be generated. So for example, if you're playing a game, as you see, within a game, you usually have this annoying backtrack that is playing, totally annoying backtrack. Hopefully, if you design games, you would design with something a bit more pleasant on the ear. But somehow I find all game tracks to be very annoying. But that maybe my age reflects there. In addition, in the games, you are often doing several actions, things like kicking a football, shooting a gun, jumping over some hoops, breathing flames. If you have a dragon in your game, breathing flames, so you need to generate the sound for breathing flames and so on. Those kinds of audio have to be superposed on top of the background stream that is already playing. So you need to have multiple audios that can be composed together on the fly and then played back on the sound output device. So these kind of things, SoundPool enables you to do very effectively. So that's the reason why we make use of the SoundPool class. Okay? I'll show you the actual code in a minute. In SoundPool class, you can specify the maximum number of sounds to play at a time. Suppose within your game you have like 20 sounds, and in one shot you need to generate all the 20 sounds, then it will sound too noisy. So in those circumstances, you can prioritize the sound, saying, if at this particular point in time I need to play out 20 different sounds, maybe just play out only the top 6 high priority sounds. For the user who is making use of the application, that is good enough to provide feedback. Your human ear cannot distinguish 20 different sounds in one shot anyway. So this is something that you can easily specify to SoundPool, saying if you have to play out more than, say, 7 different sounds, play out only the top 3, and that is good enough for the user, and so on. You can even pause and stop sounds on the fly, looping sounds, as I showed you last time, where we have this annoying thing playing continuously in the background and changing the playback. So for example, on the fly, you can change the pitch of the sound. So you could use a single sample and then automatically, so for example, if you want to simulate a cat's neck being strangled, meow. So you can have one single sound and then you can automatically adjust the frequency and then produce the sound automatically. So that can be done. And then when I don't advocate animal cruelty, but just I'm using only the example to show you what could be done in practice. Okay? So these kind of things can easily be done with SoundPool. Let's go back and look at some of the code. This example, if neither SoundPool nor media player fits your bill, you want something even more fancier and with a lot more control, then you resort to a third kind of class called as the audio track class. In the audio track class, it is a fairly complicated class to make use of. So I would suggest at this stage, don't go there unless you really have to. Okay? But for your information, I'm showing this to you. This gives you a lot more powerful capability of controlling the sound playback and so on, including things like generating your own sounds. You can specify the frequencies of the sounds that you want to generate and then automatically let the system generate the sound rather than simply giving it a sample, a pre-generated sample and so on. If you know much about sound generation and all that, this would be something that to play with. If you don't know anything about sound generation, don't mess with this class. Okay? So in this case, what it does is it allows you to stream PCM, pulse chord modulation, that is full raw audio directly to the audio hardware device. So it allows you to directly write to the audio hardware devices by using methods like this. That's why I said it's a fairly complicated thing to make use of and so on. It can be used in 2 modes, either static mode or streaming mode. In streaming mode, the application will continuously write a stream of data to the audio hardware port using the right methods. The streaming mode is useful in situations where you have an audio sample that is too large to store in the physical memory. You need to be able to read it from the file on demand and then regenerate it and so on. And in those circumstances, you make use of the streaming mode. The static mode is a situation where you're dealing with short sounds that can be stored in memory and then called in on the fly in order to generate. Again, you saw the SoundPool class providing some of those features for you. This is even more general, but as I told you, go there if you really need to. Okay? Static mode and streaming mode and so on. So, for example, in static mode, it can play the sound without needing to transfer the audio data from Java to the native layer. Every time the sound is to be played, it will directly be sent to the hardware, and so on. This is preferred, for example, for UI and game sounds that are played very often, but you want very low overhead for playing out the games, playing out the sounds, and so on. So in those circumstances, audio track would be a good one to make use of. Now, furthermore, this allows you to do things like, for example, decoding audio from any format. Now, media player handles certain specified formats. Similarly, SoundPool also handles only certain specified formats, things like MP3, OGG, MP4A, and a few other formats and so on. But if there is a particular format of audio that none of them handle, audio track is your only choice at that point. It can allow you to do things like modifying and enhancing the audio on the fly. Things like doing things like distortion, vocoding, reverb effects, and things like that. If any of you know how to do DJing, you understand how to do these things. If none of you have ever been a DJ, then you don't understand how to do these things. These things are very useful for DJs. They produce samples, audio, and so on, and so on. So those kind of things, you can make use of audio track. The issue with using audio track is that you are on your own for managing the whole audio playback and things like that. As you saw with media player, if you use the media player class, it will automatically create a background thread for playback of the music and so on. Here, you are on your own. You need to create your own threads. You need to manage everything on your own. So that's the reason why I suggest not to go this direction unless you really have to. Okay? So in comparison, depending on your need, which kind of class are you supposed to use? If you want low latency sounds like games and so on, your first choice should be SoundPool. If that doesn't satisfy, then go for audio track. If you need to play back video that has an audio track, media player, straightforward. If you play a set of short sounds many times, SoundPool is a good way of handling those things. If you are streaming audio from an external source, media player is your first choice. If that doesn't satisfy, then you have to resort to audio track. Okay? Preferably stay with media player. If you need to generate audio from scratch, if you generate audio by using mathematical formulas for combining different frequency sounds and things like that, audio track is your only choice. Okay? And there is one more thing called as Jet Player, which Android supports. For Jet Player, you need to create your audio tracks by using something called the Jet Creator audio thing. That is again a bit complicated. Unless you know how to manipulate sounds, I would suggest don't go in that direction. Okay? Background music, media player, very straightforward. And this is the different suggested methods of doing all these different things.